Tonight's video will look a little bit different because I pre-worked a lot of the work so I could hopefully make sure that I didn't make any mistakes, but then thought that I would just discuss some of it to help give you a little bit of fluency with analyzing what is taking place with the data. So problem number one, as you'll recall in class, I changed up this worksheet a little bit. If you chose to print off the new one, that's fine. Otherwise, most of the same information is present from the other one. I just got rid of the original A's from both 1 and 2. And then this particular worksheet, I added a formula that we pulled out of the class content and will not be discussing. But I know there's some of you that it's going to intrigue and want to know, hey, how do you actually do this? And so I figured I would throw it in to the bottom of the worksheet. We'll discuss that in a little bit. Problem number one, create a frequency chart for the data. We should have all been able to create a frequency chart. Your dart chart may look slightly different depending on how many bins you decided to create in your frequency table. I created, as you can see, 5 different bins. Those 5 different bins will translate into 5 different bars on my histogram. So, as you can notice, my frequencies on each of the bins, my data range on each of the bins is consistent. 3 values, 3 values, 3 values, 3 values, and 3 values. So that my data, as it's inputted into each of those bars, would be consistent as well. And that has left me with what looks to be a slightly skewed right distribution of the data when it has been graphed into histogram form. Problem number 2, create a frequency chart. And again, I created a frequency chart and I used 1, 2, 3, 4, 5, 6, 7 bins. And then evenly distributed my data. That created the following histogram. And within this histogram, we have what appears to be normal distribution. Now we're going to talk briefly about how to determine the bins. And so we determine the number of bins, or I guess the data span within the bins, by calculating this value of W. So we're going to use the above chart to calculate the value of W for this set of data. And I'm going to do this on the calculator so you can get an idea of what's going on. I've already pre-calculated the IQR, and the IQR for this problem is 21. So, I would plug into the calculator 2 times 21, because that's my value of IQR, and I'm just filling in this formula, and that equals 42. So, my formula will simplify to 42 over the cubed root of however many values I have. 1, 2, 3, 4, 5, 6. And so I have 23 values. And so I'm going to plug these in just like that. 42 divided by, and this funny looking button, second, and this x to a certain power gives me the square root of a certain power, and so I'm going to change that to now cube root of 23 and press enter. And we get 14.768. So now, if we look up at the chart above, we will see that I utilized a span of 10 units for each one of my bins, utilizing the formula for correctly identifying the span in each bin. Each bin should have been approximately 15 or 14.76 if I wanted to be more exact, but each span should have been approximately 15, and that would have left me with closer to 5 different bins in which my data would have accumulated within the frequency chart, and then my histogram would have had 5 bars. So again, I'm not going to require you to know how to do this right now, but since I know that there are some of you that are probably dying to know, how do I know if I should have 4 bins, 5 bins, 6 bins, 7 bins? This is how you determine. That's going to tell you the spacing of your frequency for each bin. So I would then take 14.76, start with my lowest value, which was 13. So my first bin would go from 13 to 27.26. Or I would have been fine with you estimating that bin value and doing 13 plus 15. So it would have gone from 13 to 28, and then the next bin would have been 29 to 43, and thus forth until we ended up having enough bins to accommodate all of our data. On the back side of the worksheet, you should not have noticed as much of a change. What's a reasonable mean for the graph? I decided at this point we're not really going to go into mean of the graphs. We're going to stick with some simpler estimations or evaluations. Number 4, which graph shows normal distribution? You should have recognized that normal bell curve on graph A. Number 5, what did you notice about the range for graph A and B? Well, each had data that existed in the 10 to 0 range, the 1 to 0 range and the 1 to 0 range. So they would have the same range. Approximately how many data points fall within the 0.5 to 0.6 range in graph B? So we would find 0.5 would be here, 0.6 would be there. So what falls within that range? And that appears to be pretty close to the 50 on my frequency. So there would be approximately 50 data points within that range. Question 7 and through 10. About what percent of students at Dodgen get at least 8 hours of sleep? So I would need to look from 8 hours moving up to greater than 8 hours of sleep. And I would know, first of all, between 8 and 9 hours of sleep, 30% of the students got that. 10% got between 9 and 10. And this appears to be 1% down here, something pretty low. I would have taken 2% if that's what you put. But 30, 10, and 1 would give me approximately 41%. I have to make the same estimation on problem number 8. How many got at least 8 hours of sleep? Again, I find my 8 hours. It appears we have 10, 9, 7, 2, 1. So that would be approximately, 29%? I think I rounded that up to 30% by using 10-10. Which middle school has more actual students that sleep between 9 and 10 hours per night? If we look at the data simply, I would say between 9 and 10 is 10, but then over here I look, between 9 and 10 appears to be 9. Well, it seems like Dodgen did. But then we have to remember that Dodgen, based on our word problem, was a rural school consisting of 100 students, while Atlanta Middle School has 3,500 students. And since my values on the histogram were representing percents of students, I need to figure out what 10% of my 100 students is. 10% of my 100 students is going to be 10 students. At the same time, I need to figure out what the 9% of the 3,500 students is that went to the large city Atlanta Middle School. And 9% of 3,500 is 315. So Atlanta Middle School definitely had more middle school students, actual students that slept between 9 and 10 hours per night. Which middle school has a higher median sleep time? Well, simply looking at the data, we can kind of work backwards on our percent values until we figure out which median has a higher value. And we're going to talk more about medians and means tomorrow in class. So right now it was just to try to get you to start thinking about it and how could you look at the graph and make or draw those kind of conclusions. We'll go over this homework in class tomorrow and we will discuss it in more detail.